Good day and welcome to AFD'S Academy. I'm Arthur Francis Deba. Today I want to show us how to carry out column chromatography. Column chromatography has to deal with our mobile phase and our stationary phase, but the separation has to be something colored most times. But there are situations whereby it may not be colored, it doesn't still matter, but we'll be able to identify what we want and deal with it appropriately. Today, we have an extract. It's greenish a little bit, but this is what we want to extract. We want to collect a pure sample of these. And here is our column, which we're going to be using. This is a standard column for organic chemists. And if you look here, I have my silica gel. I have them activated, and this is my alumina. They are all activated. Now, if you look at this column, normally every column we have to start it by introducing our cotton wool to prevent the influx of the silica gel and all of that from getting out. But this one is designed in such a way that we have our cotton wool, a substance which is representing our cotton wool in this sense. And here is our retort stand, which we're going to use for clamping, and by so doing, we're going to be fine. So I'm going to begin by now introducing first the substances they're in. So we begin with what? Silica gel first. Silica gel will be in here. I will have to arrange it, then bring in my alumina, then introduce my extract, and in that course you see how that plays out. Although I have a lot of little beakers, these beakers are they will be used to take out the fractions. What will be coming out, this is what we're going to use. So let's begin by filling our column. So I have my silica gel being introduced. So in each scenario, when you introduce them, we tap so that they will be able to arrange properly. It is pertinent that we do this tapping in order to have a smooth ride in the course. So I'm going to be introducing more of this. And it is important that this must be done before a sample is being sent for gas chromatography mass spectrometry analysis. If this is not done properly, the sample will not be pure enough, and that will give them a whole lot of trouble. So in the course of that, before any of that is being done, either GCMS or even IR or NMR, it is important you have your sample cleaned up in the process before that goes on. So I'm going to take almost like half of this so I can add some little more. Okay, so this is almost half. I wouldn't take more than this. And this is the dry method of column. The wet method is technically better because it saves reagent. With the size of this kind of a column, a lot of reagent or substances will be used in the course, and that is not too nice. In case you do not have much money, it's preferable you use the wet method. So now I have taken almost half of it. So I'm going to introduce my alumina. So this is silica gel, alumina comes out. If you look carefully, you will see that the alumina is different from the silica gel. You can even see the mark therein. But in all things, I'm going to tap to have them adjusted in order to continue moving successfully. So let's see what we do in the course of that. So let me take more. I'm going to add that here.
Okay.
Each little you put, you tap it. I have to tap arrange it well for it to be well packed. That's the reason why the tapping is done. It has to be packed properly. Otherwise, we have challenges. There's a lot, man. The reagents required are quite a number. So, although it's supposed to be half-half, but it doesn't seem matter. Let me just add a little more. And for the course of this, our experiment today, we're going to carry out just once. We're not going to carry out double or triplicate, just one time. That's what we're going to do. Okay, this is good. So, let me keep this ones by the side. Bring in my clamp. I have to clamp it. So let it be locked for the time being. Let me clamp it now. Okay, and it has to be very vertical. Alright, so now this has been fixed. The next thing I'm going to run the solvent down to see how it goes all through. Although it's going to have the surface of base a little perturbed, it's going to distort the surface a little bit. But that is what it is because it's a dry principle. But if it were to be wet, it wouldn't have affected it. But then I will still proceed. Yeah. Let's see what we do. Okay, we can start with this. This is our solvent, which is methanol. If you look, you see that it's actually going down gradually. But I need a lot of base, quite a lot. Okay. So gradually it's going to be going down. It's a mixture, the solvent is a mixture of methanol and NSN. So I'll be able to take out the polar and the non-polar, the ring, so that when we analyze it, we'll be able to see through GCMS all the polar substrate and the non-polar substrate there. So that is it. It's open right now. It's going to be going down gradually. Yeah, also I can lock it.
In the name of the Father,
But let's leave it open.
Holy Ghost, amen.
It's going to be going down gradually. It's going to take a little time in the course of that. But let's see. The process is slow. The process continues. Now we will begin to have drops. This solvent have to clean up the system first. So this one will be taken out. Well, once the solution or the solvent gets to the brink where the alumina is, the extract will be introduced and the process will also be monitored. Although it's a gradual process, this what we're collecting now is not a fraction yet because the extract has not been introduced. It's just to collect the cleanup the system until when that gets to the brain, that is when this will be introduced. And this is a gradual process because it has to do with the reaction of the mobile phase, which is the solvent, and the stationary phase, which is the alumina and silica gel. In that process of interaction, it cleans out the system and bring out only a pure sample which is required. So it is a slow but significant process which must be taken. So while we're here, we're going to be waiting until when that gets to that level. You will see therein how we are going to move in the process of introducing our extract and see how that moves on. So for the time being, we are going to be patient. Believe me, we have to be patient. If you look at the work now, the process, like I said, this is a slow process. We have to be patient. Then you see the solvent has moved down to the edge here. So from now, I will be introducing. This is just a fraction which we are not using. It's just collecting it. So when I introduce the extract, we'll begin to monitor the process again, and I will add more solvent, and we're going to see how that all is going to go. So at least it has moved to an edge. So it's time now. I'm going to add this. Let's see. This is our extract. Good. So that is it. Now the process continues. Like I said, it's a long process, and the reason why this is slow is because of the compartment, and we use a very big adequate column. So it's meant to be a little slow or slower than usual if we had used a small one. So I really need something standard. So I have to use a standard column in order to achieve that. So the process will definitely continue, and we're going to monitor the flow rate until when it gets to a point where we are certain that the substance are being now collected. Then we change these. We remove these, which is a waste, and introduce these, which will be collecting the extract directly, which are meant to be clean. And in that sense, when that is done, this is what we are going to pack into the vial bottle, probably this, put them in here, seal them up, and send them out for analysis. You can use any kind of bottle which you want to use. The reason why we use something like glass is because the NSA therein react with rubber. If you use NSA and you do not take proper precautions, it will melt the rubber. So I have to use something which is glass, which will never melt or be melted. So the monitoring process definitely is going to continue, but don't forget that the polar and the non-polar solvent, which is a mixture of NSA and methanol, is to interact with the sample. Then the polar substrate will take out the polar component of the plant, and the non-polar substrate will take out the non-polar component of the plant, and that will be collected as one fraction. And that is the fraction which we're going to analyze, since it's a compound analysis. So we're going to analyze all of it and be certain what is present therein. So it is just it. So the interaction continues. The mobile phase is the solvent, and the stationary phase are the silica gel and the alumina, which are being packed therein. If you look carefully, you will see that the movement of a colored sample is going on gradually. So we're going to wait. Like I said, it's a long process. We're going to wait until we will begin to collect our fraction, which we're going to use. So far, so that is it. We'll continue to wait. So let's see what happens before the day runs out. So like I was saying, the gradual movement of the colored extract, you begin to see the tracing down to this level. If you look carefully, you see that the colored substances have gotten to here. Now, I've not been in a hurry to maybe remove this and replace the fraction or this. I've not been in a hurry because what I'm collecting now is still the solvent that was earlier introduced. Until, okay, for example now, let me replace this. I can now take this out and introduce this. So this I'm going to discard, all right? I'm going to discard this. And whatever is coming in here, I know does not contain the active component here because I can follow the color substance. I'm seeing the movement, so I can follow it. So I know it doesn't involve it. But in a case where it were to be colorless substance, it means that when you trace the movement to a certain degree, you should understand that you should begin to introduce, when this one is full, you take it out, but we use vial bottles, which are smaller bottles. So in that case, when one is full, you keep it by your side, you continue until the whole extract is being collected. And those ones that are being kept by the side, we will test them using TLC, thin layer chromatography, to monitor to know whether it contains the active component or not. Otherwise, you wouldn't know which one contains the active component and which one doesn't. But in this case, we are able to notice or see the color substance as they're moving and their interactions. It's a gradual process until when the color substance start dropping. I now know that I'm collecting what? The fraction which is required for analysis. And that is simple. I know that. I just take it, assemble what I need, and off I go. As easy as that. So this is a gradual process. Like I said, we have to be patient in the process. If you check too well, we've been on it for a while now. So we are all still going to be here monitoring the principle and the process gradually. As this tends to go down to this edge, I will have to now introduce more solvent, and the process continues. That is it. So we will see to the end of it. Here we are, and we're going to follow the process stepwise to the finish. And after that, I will show you how the result goes. So let's continue monitoring. All right, I think this has been very successful. If you check the trend, you see the greenish color all the way down, and we're beginning to collect the fraction, which is green. So by virtue of this, you know that you're getting your active component directly. You do not need to be doubting what you're doing because it is obvious, one can see. So if you now come up here, we've been told never to allow this thing to dry up. So I will be introducing some more solvent. Okay, although it's meant to be very slow, but we do not have the patience for that now after we're collecting what we need. So, and this is it. The greenish color continues until when I get the quantity which I desire. Well, once I have that quantity, I'm good. So I'm going to take at least up to this 50 ml and pack it for the further analysis, which I will have to send it for further analysis. But by virtue of this, it has been very successful. And secondly, remember, the reason why we have to use a mixture of polar and non-polar solvent is to ensure that whatever we're going to collect from here contains the two. But if I were to use just one, let's say methanol, I would be forced to collect only the polar substrate that are soluble therein. What if what we're looking for is in the non-polar substrate? Then our work would not be complete. And by the time we go further in the analysis, we'll not know what we need. So this is an analysis whereby it contains the two, be it as it may, whatever I need therein. If I need the polar substrate which contains the OH group and the oxygen group, I'll see them. The non-polar, the hydrocarbons without the oxygen therein, I'll still see them. Then from the GC, which will give me a broad spectrum of all the chemical compositions therein, I'll be able to sift out what I need. And now say, okay, I'm looking for this particular compound, a peculiar compound, which probably may possess some medicinal ability. Okay, this I have seen. If I am meant to go further to maybe isolate, that will be a chemistry of its own, which means I must have to introduce my TLC in the course of doing that. And I have to check the fractions which I'm collecting, run antimicrobial activity, probably with some pathogenic microorganisms, to know whether it has the ability to inhibit those pathogens or pathogenic microorganisms such as Staphylococcus aureus, Escherichia coli, Candida albicans, and so on. So when that is done, if I or probably you who may be interested to know what we're doing, if you're interested to further on to find out what are those isolates which have the capacity of inhibiting microbial growth, you want to know the structures therein, you have to go further to elucidate, which is characterization, to determine use your NMRO and use your IRO, infrared spectroscopy, nuclear magnetic resonance spectroscopy, even the UV visible spectroscopy. You can use all of that. And from there, you'll be able to really determine whether this is what you want or this is or that or thereabout what it is. But this is principle of organic chemistry. It's core organic chemistry. Once you understand this, in one particular reaction, you can get everything which you need, get the ones out of the bulk which is given to you, and your actions will be complete. So this is it. We've gone so far, we're beginning to get our fraction, which is colored. And if this were to be full, I take it out and introduce another, but I do not need that. But once I have up to 50 or 40 mil, that will be sufficient for me to divide it into different vial bottles and analyze whatever I need. So the trend will continue. I'll continue to monitor until I have close to 30 to 40 mil. Right now it is within the 10 mil mark, but it's still fine. And this is how the trend goes on. And let's continue to see and monitor. We'll see to the end of it. All right, so far we've been able to do a good job. Remember, like I told us earlier on, it was the solvent was a mixture of a polar and non-polar solvent, the N-azine and methanol. So from the reaction here, if you check our fraction, you realize that the extract is more polar, is more soluble in the non-polar solvent, which is N-azine, because of course methanol will be heavier than N-azine, so methanol will be down, N-azine will be up. So by so doing, it will contain more. The extract is found more in the non-polar solvent, which is the N-azine. So had it been, let me close the tab, I think we've gotten what we want. So had it been we use methanol only in this process, we would have been able to get almost nothing in the extract. The active component weren't having much affinity to the polar solvent, so almost minimal of it would have been taken. So what we have here, if you analyze this in a GC, you will get compound, but it will be very minimal. But this other one contains more, which you can even see the color. So by virtue of that, I would take that of the non-polar by using my micro pipette and collect them out so that I can send it for analysis. It is obvious that this side contains more of the active component than this side, so there wouldn't be any need of me taking the two. Maybe for the sake of justice, I may likely take the two, but to what ends is it if what I need is found in this last side? So I will begin by collecting this one. So I'm collecting that, put it in my bottle. Okay. Okay, this side contains some polar. So that's why it's going also, I'm going to bend it. So if you look here, you see that some polar solvent are therein, so it doesn't work effectively. But this is a pure non-polar. But I'm still going to take them. Okay, good. Let me put it here. Okay, so I've been able to collect my pure substrate extract from the column, but this one contains some polar solvent therein, so it is not 100% non-polar now, but now it's a mixture, even if you look here. But I'm still interested in mixing them both. It contains a little. I need it to contain a little of the non-polar. So in the course of analysis, when we take what we need for the non-polar, that of the polar, we'll see we can still get one or two compounds therein. So by virtue of this, you see, so before the sample will be aspirated in a GC analysis, they take a little of this, aspirate it for the non-polar, and take a mixture with this and also aspirate for the polar. But if the person is just interested in just this alone, they can decant it and get what we need. So this is ready for analysis. So we've come technically to the end of the work. Remember, the principle was straightforward. What we did first was to put our cotton wool first, but now in this situation where the column contains something representing the cotton wool, we only entered our silica gel first to almost halfway up, followed by alumina, and the solvent was introduced, which was a mixture of a polar and a non-polar solvent. So as it started dripping, we now have to introduce our extract when it gets to the edge, almost to the edge where the alumina was. So we introduce our extract, which was colored green color, and we're able to monitor the principle or the process gradually as it continues dripping until it gets to where the color substances are, which depict the active composition of what we need. And that we collected, which you can still see, with the help of this hand pipette, we're able to pick out what we, or hand dropper, or a dropper, we're able to pick out what we need, and here we are. So this can be sent for analysis. So do not forget the principle contains what? The mobile phase, which is the solvent, and the stationary phase, which is alumina and silica gel. So the interaction between the mobile and the stationary in relation to the active composition therein give us the pure state of what we need. And that is it. There is. So we've come to the end of today's work on column chromatography. I really appreciate all of you probably who have been following me from time immemorial. I would advise for those who have not subscribed to do that, especially the chemists that probably need this majorly in organic chemistry, and the biochemists, even the molecular microbiologists. You also need this. So it is interesting so far. I will have more of these kind of videos, maybe on thin layer chromatography and many other kind of laboratory work, and also how to use our digital ultrasonic cleaner, which will be any other analysis, to see how we can use it for extraction, which is one of the most efficient pathway or method of extraction because it deals with sound wave. All of these, will unravel them as time goes on. It has been my pleasure having you today. Thank you, and do have a wonderful time.